So energy auditing is required the number of instruments, and these instruments are based on the type of energy audit to be done. Energy audit for electrical energy, if you want to do in the industry, then we require the instruments which are used for measurement of all electrical parameters. Electrical parameters are like this: current, voltage, power, power factor, reactive power, active power, frequency and speed of the drives, etc. These are the parameters required for measurement of parameters of electrical energy audit. So there are certain instruments which are used for this purpose. Secondly, if we go for analysis of thermal energy, in that case we have to require for parameters for measurement of calorific value of coal, then thermal energy constants, and different type of gases produced by burning of coal, like carbon dioxide, carbon monoxide, oxides of sulfur, oxides of nitrogen, etc. Then we want to measurement of flow. So for flow measurement we require flow meter. Then sound measurement, it is required for noise and vibrations. Vibration in the machines, whatever the level of vibration is there, it is measured by vibration measurement. Then water purity measurement, it is required for this total dissolved impurities, that is the TDS. We have to find out total dissolved sediments or solids in the water. So that is required for maintaining the quality of water to be feed in the boiler. Then speed measurement, we required speedometer or tachometer. So here different type of measurement required. For physical quantity we required length, weight and temperature. So length can be measured by tape, and weight can be measured by weighing machine. It may be digital weighing machine or a spring loaded weighing machine, mechanical type. And for temperature you required the pyrometer for the furnace's temperature, and for direct temperature reading with small range we required thermometers. So then for finding out the humidity in the system we require hygrometers, or for moisture content and the relative humidity. So here I will give the types of instruments which are used for the requirement of energy audit in the different cases. So you write down the name of the equipment and along with their functions. So first instrument is a power analyzer. In power analyzer there is it is also called power meter. This power meter directly measure the power in terms of watts, and also measure the reactive power, that is kVAR and kVA, that is the apparent power. This can be measured by this power analyzer, and this will also give power factor, kilowatt power, current, voltage and kVA. So these 3, 4 or 5 types of parameters can be obtained from this one particular meter, that is called power analyzer. Then second is the combustion analyzer. This combustion analyzer, this instrument measure percentage of oxygen, percentage of carbon monoxide, percentage of oxides of nitrogen, oxides of sulfur. This is required in case of the furnaces, or where oil fire furnaces are there, or boiler in which we use the hard coke for burning in the furnace. So you required all these parameters in case of thermal energy, where we use boiler or furnaces. Then third is the fuel efficiency monitor. This certifies the values of common fuel or some standard fuels are fed into the microprocessor, and this instrument measure the flue gases, temperature and oxygen content, and the calculation of the combustion efficiency. So this is the fuel efficiency monitor. This is the third number item. It is then flue gas analyzer. Whenever after burning the flue gases are obtained, so we have to go for control of pollution in the system. We have to measure this type of again the oxygen level, carbon monoxide level, carbon dioxide level, then sulfur dioxide measurement, and the combustion efficiency of the system or the boiler. Then we require another instrument number 5, that is contact thermometer. Thermometer are two types, that are one thermometer is contact type, in which we directly put in contact with the system of which the temperature is to be measured, and second thermometer, it is uses non-contact type, that is called infrared thermometer. So when the temperature range is very high, in case of 1000 degrees Celsius, in case of furnaces, so we have to use this infrared thermometer, and from distance place we can measure the temperature of such type of equipments, like all types of furnaces and ovens which are operating at high temperature. High temperature means above 400 degree, 500 degree, 1000 degree, like this. And contact type thermometer, they are for low temperature. Low temperature means where we can directly connect this thermometer with the system and that give direct reading. This type of measurement of temperature of hot air and hot water, flue gases, by insertion of the probe into the stream of the flow by using the leaf type of probe. And this type of meter, that is contact type meter, it is in direct contact with the flow of the gases or the flue of which the temperature we want to measure. And infrared thermometer, as I have told you, it is for distance measurement. Then pilot tube and manometer. For measurement of this instrument is useful for measuring air velocity in ducts. Now in many cases when the centralized AC systems are used, then velocity of air in the ducts, and also for the control in system for air circulation, we want to measure the velocity of air in the pipe or ducts. So for this we will use the pilot tube and manometer. They are combined name of this pilot tube and manometer. So this is for measurement of velocity of air. Then water flow meter. Now whenever in the industry the use of water is also compulsory, in case of textile industries, pharmaceutical industries and other industries where flow of water for preparation or manufacturing of steam is required, for that you require the water flow meter. This water flow meter is also a simple device which can be directly connected in the pipeline, and this will directly read the flow of water in terms of how much volume of water discharged through the pipe. So this instrument follows the Doppler effect in the utilization or ultrasonic type of principle which is required for measurement of flow of water. So they are also contact type and non-contact type, both are available. Then speed measurement. For speed measurement there are two types of instruments available. One is the requirement of this speedometer, they are also called as tachometer. And this tachometer are two types. One is contact type, that is analog scale. With the analog scale there is a pointer, and when we put in contact with the rotating body, then it will directly read the speed of that particular object or that particular machine or motors. And in non-contact type of meter, they are digital type, in which what we have to do, we can measure the speed from distance place, and in that case we put a tap or a particular point on the wheel, and by infrared or the light radiations we can measure this speed of that particular object with the help of this non-contact type tachometer. So these are also easily available in the market, and they are very comfortable in size, so that we can carry it even in our pocket. So they are in so small in size, so they are used for measurement of speed of any rotating object, whether it is a machine, motor, drives, or any type of engine part or engine wheels which are required for measurement of speed. Then next is the leak detector. Normally what happen, the leakage, it is a big problem in those industry in which fluids are used as a material for manufacturing, in which the oil flow is also there, water flow is also there. So leakage detector is required for all these case, either for water, oil, gas, whatever flow is takes place in pipelines. So we want to measure the measure or detect the leakages of gases and compressed air. This is by the ultrasonic instrument. This is the ultrasonic instrument by which we can measure the compressed air leakage or the leakage of the any gases in the system. Along with these gases and the compressed air, we also measure the flow of the leakage of liquid also. Liquid in case suppose diesel is there, petrol is there, kerosene is there, or any other pipeline in which any other type of liquid is flowing. So if there is any leakage, then by this particular meter leakage detectors we can find out this particular measurement of the leakage in the system. Then we required a Lux Meter for lighting arrangement. Definitely according to standard there is some values of light energy which is required on the surface, and according to requirement of the surface, whether the same type of energy or same quantity of energy you are it is emitting from the source or not. For measurement of this we have to use the Lux Meter. The measurement, this instrument measure the illumination level. It has a photo cell which senses the light output from the source, and this light output from the source when measure, then we can compare with the help of this particular instrument that requirement of light on the surface is sufficient or not according to the requirement of the process. So in this particular type of instrument, the light output is converted into electrical impulse, and which are then calibrated in terms of lux. So that will measure the illumination in the unit of lux. Then next instrument used for the purpose of thermo hygro clock. This thermo hygro clock is this measures the temperature and relative humidity. This particular instrument used for two purpose, to measure the temperature as well as relative humidity. This is called thermo hygro clock. So this is the item number or instrument number 12. Then we go for next for measurement of noise. So sound level meters are used for this. This is very useful for measuring the noise level in the industry. So noise level as decided by the pollution control board. According to that, in the any system we have to manage the noise level. So for noise level we use this particular type of instrument. This is called sound level meter or sound level detector. Then there is another instrument, number 14, it is anemometer. This anemometer, this measures the velocity. So velocity of air, normally what happen, velocity of air normally required in the outer area where this wind pressure turbines are running. So velocity of air is required to find out the wind velocity for finding out the efficiency of wind pressure turbines. So for this purpose we use the anemometer. Then there is another instrument, that is psychometer. The psychometer is useful for measuring the bulb temperature, that is wet bulb temperature and dry bulb temperature. So WBT and DBT, this is the dry bulb temperature or wet bulb temperature. For measurement of this we use psychrometer. So psychometer is also one instrument used for the purpose where it is required. So these are all the instruments which are measure the quantity, which are mostly non-electrical type of quantity, which is required in those type of system where these parameters are wanted to be measured. When we go for electrical system, in electrical system we require power factor meter, then frequency meter, we required kVAR meter, we required watt meter for power measurement. Nowadays a combined unit is also available, which is called power meter, and which can measure all the parameter, current, voltage and power in terms of active power, reactive power and apparent power. But separately, if you want to measure current, voltage and frequency, then there are different meters are available for this purpose. That is in case of measurement of current, you can have a ammeter which is measure amperes of the load, which range from 1 ampere to 600 ampere, 500 ampere capacity. It is available in the market. Then if you want to go for measurement of voltage, so in case of voltage you required a 3-phase voltmeter. The voltmeter phase to phase voltage we have to measure, and when phase to neutral voltage we have to measure, so we require single phase voltmeter also. So voltage with respect to phase to phase we have to measure in 2 phase, so it is 440 volt. So definitely we require 3-phase voltmeter. And when we want to measure voltage between neutral and phase, then we required only a single phase voltmeter in which neutral and a phase is there. Then for measurement of power factor, we are having a power factor meter. With the help of that we can measure the power factor of the any system connected with 2 wires in the 2 phase, and we can measure the power factor of any system in which electrical energy is used. And for the load power factor, we connect the 2 knobs or 2 probes are given in that meter, and we can measure the power factor. Then next is the frequency meter. So there are 2 types of frequency meter are available. One is vibration reed frequency meter. This is a mechanical type of arrangement in which the strip of metal, they are vibrating according to the frequency of the source, and for that it is calibrated in terms of on a scale in the analog form, and it will give the frequency of the source. So this frequency meter is called vibration reed frequency meter because it is totally based on vibration of the source, which is converted into frequency by calculation. Then one is the non-contact type frequency meter, in which vibration reed is not there. It is a digital type. You connect it in the system and directly it will show the digital value of the frequency of the system, or the drives, motors, or whatever type of other arrangement is used in which frequency requirement is there for calculation of any other electrical parameter. Then we required a phase sequence meter. Phase sequence meter It is required for judging whether your system is running in proper sequence of three phase or not. So that is RYB is normally a sequence required for three phase system. So a sequence meter is used for measurement whether the system are properly connected in sequence of RYB. So it will measure the sequence and it is set up with that indication that your system is running in proper sequence of RYB in three phase system. Then other equipment required for measurement of electrical items or electrical parameters, they are all I have covered, and apart from that whatever type of other instruments required for different form of energy use, that is thermal energy in case of boiler and furnace, the what type of instruments we have used, we have to use, they are also covered by me. So in all I have given you about 20 to 25 instruments name and their purpose and how they work. So you have to list out these all instruments, and their diagrams are not available in form of the line diagram, but their photos are available in the books. So I will just upload these photos. They are camera copies photos, and this I will upload on your WhatsApp group, so you can just can see that how these meters are looking, because whenever you go in field for purpose of actual audit, then you must know which type of instrument you are using, so how it looks. So by look wise you can identify the instrument. So for that I will give the photo of these particular instruments on your WhatsApp group. So measurement of all the parameters which are required for this purpose, for energy audit in any system. Any system is, there are two type of systems are there, either you are using thermal energy or you are using electrical energy. So in thermal energy what type of measurements are to be done, I have taken that, and what type of measurement is to be done in case of electrical energy, that is also I have taken. So this finishes your topic number 2, that is energy audit. So last time we have discussed all the steps in energy audit, classified the energy audit, scope of energy audit in power sector, then different steps in and methodology of energy audit. So this type of point wise discussion I have given to you, and you have studied all this, and you prepare rather your notes on the basis of my lecture, and if any problem you have to you can ask me. Then now for some points to be covered in steam energy, that is a output of a boiler. So in that case steam generation we have to go for some points, that is the selection of boiler to achieve fuel economy. So there are two type of boilers available in the market or in the industries. One is fire tube boiler and one is water tube boiler. So according to use you have to select which type of boiler for achieving maximum economy or maximum efficiency. Then techno-economics of the fuel substitution. Then also this is a point whether you are having the number of alternatives for fuel use for the boiler. So you have to compare the techno-economics of the fuel in the particular type of boiler for the purpose of burning. So definitely in this you have to find out the efficiency, that is thermal efficiency given by the fuel. If maximum, then you can use that type of fuel in that boiler. Normally coal is required for the boiler furnace, and in the form of coal it is not directly raw form, but it is pulverized coal. This pulverized coal increase the thermal efficiency of the coal, and this will give the maximum heat energy for the boiler to convert water into steam. Then improving combustion efficiency, whatever type of arrangement you have to use, that by difference of level of air flow by induced draft and forced draft, you can increase the efficiency of the boiler. Then increase the generation rate of the steam, that is the steam capacity. So that is also increased by increasing the fuel efficiency and discharge of water through the tubes, or the either it is a water tube boiler or fire tube boiler. If it is a water tube boiler, then you increase flow of water in the tube and excess heat will be provided surrounding to the tube, so maximum efficiency you can get for generation of the steam. And if it is a fire tube boiler, then fire will run inside the tube and water surrounding the boiler, the tubes. So in this case also, if you increase the efficiency of the running of the heat or the hot air or hot gases in the tube, then it will increase the surface area surrounding the water, and that will increase the efficiency of the boiler by giving maximum heat to the boiler, or maximum heat transfer to the water, and which convert into steam as required for the purpose of or the process of manufacturing. Then design of the monitoring of the system to affect the economy. The design of the monitoring system to affect the economy, this is again all will come with the number of instrument to be used for controlling the parameters, which parameters control the economic generation of the steam in the system. So for that I have already given you the gas analyzer, flow meter, leakage meter, or this type of anemometer. These all instruments are required for analysis of the economical effectiveness of the boiler operation. So these data can be obtained from use of this meter. Then steam distribution, it is also one point in this particular topic, in which we have to when it is steam is generated from the boiler, then how it can be circulated or distributed for the process. So there are certain points in this, the design of steam distribution system to according to need of the process in the house, means in industry wherever steam is required, you have to run the different type of pipelines from the boiler, and they are completely sealed so that there is no leakage or there is no loss of heat from that. It should be totally thermal insulated, so that the heat of the steam, it is not dissipated through pipe to the atmosphere, and the maximum efficiency you can get by designing this type of distribution of steam for the different process. Then for next point, that is the redesigning of the existing distribution system to increase the production rate. For production rate, naturally two things is required. One is to increase the rate of flow of water in the boiler, and second is the rate of flow or charge of the coal in the furnace. So by increasing both the things, by flow of water and by increase the input in the furnace in form of coal, the burning will be fast takes place, so the steam generation will be takes place fast and production rate will increase. Then reducing the work to be done by the steam. Now naturally, whenever steam is to do the work, normally to run the steam engines or in some process for running other type of machine by the steam, so we have to control that reduction of the work to be done by the steam. Means more and more load should be reduced on the steam for the mechanical conversion of steam energy into mechanical energy. So if you save energy in this way, then naturally the coal or the steam generation can be economically produced by the boiler, and this steam energy which is used for running the mechanical load, this should be reduced by applying proper type of gears and proper type of power transmission equipment for that, in form of belt or V-belt or flat belt, gears and etc. So that will be reduce the energy consumption, this steam consumption in case of running types of the mechanical parts of the system, running or rotating parts of the mechanical system. Then insulation of steam pipelines and hot process equipments. This is, I have already told you that you require to do the thermal insulation in the pipeline from where steam is passing, to avoid any type of the steam pressure loss as well as steam temperature loss. Then avoid the steam leakage. For that we have already told you that we have to use the leakage meter, that is leakage detector. So by leakage detector we can do for this type of activity to prevent the leakage of steam in the system. Now overall conclusion for energy audit, you have to write one para that I am speaking to you. You write down this para giving the heading conclusion of energy audit. So conclusion of energy audit I just give to you, that is the final article, conclusion of energy audit. The energy audit may be considered as similar to the monthly closing statement of an accounting system. One series of entries consist of amount of energy which were consumed during the month in the form of electricity or gas, fuel, oil, coal, etc. And our second series lists how the energy was used, how much energy was used in lighting, in air conditioning, in heating, in process, etc. Energy audit process must be carried out accurately enough to identify and quantify the energy and cost saving that are likely to be released through investment in energy saving measures. So this particular conclusion he has given, in which just like our accounting procedure for monetary audit, matlab audit to be done for accountancy, similar to that we have to go for audit of the energy in the system, and for that we have to list out all the sources of energy, from where it is coming and how these sources are used. Then what is the output of the sources, you have to list out. Then where are the energy uses are there in the system, you list out this, and they compare both according to standard, how much energy required for different work point and how much energy is being supplied to the work point. So if the difference is accurate as per the design, then there is no problem for improvement is required, or there is no steps to require improvement. But if there is a big difference is there beyond the specified limit, then you have to go for improvement of the system in form of efficiency to reduce the energy losses. And whatever type of instruments you require, whatever type of conservation equipments are required for energy, that you should apply for this, and according to that you should manage all these activities, so that you can reduce the energy consumption on every work point so that the economical use of the energy can be finalized. And this is what the purpose of energy audit. What is the last stage? The last stage is that if there is a loss takes place more as compared to our specified limit, losses in the system will be there. Why? Because no system is ideal in practical. So losses will be there, but what is our objective? That we should reduce losses to the minimum, and that minimum range I have told you that 97% efficiency we should obtain in the system. 3% losses may be considerable, 3% in the practical form. Ideally it is 100%, but ideally system is not available and it is only a matter of theoretical discussion that you can obtain a ideal system for 100% efficiency, but practically it is not possible. So our objective of energy audit to bring the system up to maximum possible efficiency, that is around 97% of the system energy input, that is energy input and output of that energy, it should have that ratio so that it should come about 97%. 3% losses may take place during the process in different points that can be managed and that can be considered rather for the purpose of calculations. So these are the points which I have discussed, in which I have given you the energy audit conclusion for energy audit, and all type of steps we have discussed. Then energy and material balance also discussed in my last lecture. Then energy instruments also I have discussed. So this particular topic is finished today. Now next time we will take your next topic according to syllabus, that is the waste heat recovery system. And this waste heat recovery system we will discuss what are the sources of waste heat recovery and what are the sources of waste heat. First we will discuss, and according to that waste heat, how it can be used by the different type of instruments. So diagrams in this particular topics are also given in number of types, that is type of recuperator, type of heat regenerator, type of heat pipes and all that. So these diagrams are slightly complicated, so I will not draw on this particular board, but I will provide you the drawing of these all the equipments which are used for use of the waste heat, and this can be, you can copy from the diagram which I have given. You have a practice of these diagrams, because normally whenever question asked, you have to answer with the diagram to secure maximum number or marks in the exam. So I will provide all the diagrams according to your course, and these diagrams you should study properly and have a practice of drawing these diagrams. So next time we will discuss waste heat recovery system. So in this we have to discuss sources of waste heat, advantage of waste heat recovery, and the commercial type of waste recovery device. So these devices have the diagram portion. There are number of devices used for heat recovery, in which heat recuperator is there, then heat regenerator is there, heat pumps are there, and heat pipes are there. So according to your syllabus, whatever type of these devices to be covered, that I will take in the next lecture, that is waste heat recovery. The heading of the topic is waste heat recovery. waste मतलब ऐसी हीट जो सिस्टम में यूज़ नहीं आती हो, या सिस्टम में यूज़ आने के बाद जो बचती हो और डायरेक्टली एग्जॉस्टेड टू एटमॉस्फेयर, ऐसी हीट को हमको कलेक्ट करना है और उसको यूज़ करना है फॉर अदर प्रोसेस फ्रॉम दी मेन प्रोसेस after the use of man process rather. So this is for all for today. Thank you very much.